Assalamualaikum warahmatullahi wabarakatuh. Welcome to EMJ 32304 Polytronics 1, which is previously known as EET 307, and the subject is known as EET 307 previously, but now it's rebranded into EMJ 32304. And doesn't matter what the name is, but the main context is that we are going to learn Polytronics 1, which is the basic of Polytronics inside this or throughout this subject or syllabus. So later you shall have Polytronics number 2, and which is we'll discuss details regarding Polytronics and their applications. So the basic of the subject now is on the Polytronics 1. So you have to master this Polytronics 1 by right, because throughout your career later you shall use this information or the knowledge that you learn from this subject. Okay, please put or bear in mind that the subject you are learning is not only for you all to pass the exam. Okay, so just be understood that the things that you learn here is very important, because we are going to learn only the basic things inside throughout our university life environment, and later we shall expand during our career. And maybe you're going to be engineer or not, but the basic things that you learn here will be benefit, and will be a benefit, even though you're going to open your own business later on. So the basic things that you learn inside Polytronics or other subjects are going to be benefit, and you're going to use it, and you're going to expand it, even though the basic things you learn here. So it's just not for your exam only. And okay, what the syllabus is all about. And so the main things that you're going to use or you're going to learn throughout the subject is on the converter, actually. Converter. So the conversion, we're going to going to learn about the conversion of one, not energy actually, from one pattern or one source pattern and to another pattern using power electronic switches. So we are going to learn about the converter or power processor. Power processor. So we're going to learn about how you're going to transfer from one source of or pattern of power or voltage, current or power into another form, either in AC or DC later, or another shape. So you can draw more throughout the power processor here, and or what's so called a voltage or current processor lah. So we are going to process the power here, which is P equal to VI, and even it is either voltage itself or the current itself into another shape of maybe higher voltage with low current or low voltage with high current. So we're going to use this converter to convert such pattern, initial pattern, into another pattern. Okay, throughout the conversion we shall use Polytronics switches. So the switches is referring to MOSFET, IGBT, diodes, SCR, switch control rectifier, what else, BJT, bipolar junction transistor, all the switches that are conducting or will conduct high current, high voltage source. Okay, so now we are talking about power processor. Maybe you have learned about signal processing and signal processor, or audio visual processor, but now we are going to use or going to learn about power processing. Okay, power processing. So in the meantime, I encourage you all to have a sketchbook or what's it called, a scratchbook and a logbook or whatsoever you call it. Means that during my lecture, I'm not sure about other groups, but for my G3 here, and I'm going to conteng, draw around, sketch around, and I expect that you all also should do the same thing, because I know that from my experience, sometimes when we learn or when we be in class, we feel that we understood, we are able to grasp what the lecture is talking about. But after sometimes the memory is lost, because we are not going to learn only power electronics here, we're going to learn other subject as well. So it might be that the theory that we learn here will be will disturb or will mix together with other subject. So at the end, when you enter the exam hall, the theory of other subjects entering our subject here, maybe our subject theories going to that subject. So you shall create the new formula inside your exam hall at that time, because of your theory that you learn is not firmly attached to your brain. So to help you all to intact the theory that you learn here, so I expect you all to have a sketchbook or logbook, such that you can draw around. You can draw around, you can make notes throughout our lecture. Okay, sorry for the long hours of lecture here, but this is important for you all to memorize the material that you learn throughout the class. Okay, one thing is that conversion. We're going to learn about conversion, convert from one pattern to another pattern, maybe from low voltage to high voltage level, from low frequency to higher frequency. So the converter will play the rules. So then we need what we're going to learn here inside the subject regarding how to analyze the power electronic converter topology. So when we convert the power, voltage and current, so we have many kind of topologies. From certain DC to 1 DC level, there will be several kind of approach, maybe high end, maybe low end, maybe medium technology. So different kind of topologies, so different kind of analysis you can do or you can perform to understand the process for this operation. So how you're going to understand that is by simulation. So that's why we use PSIM as our simulation tools. We have other kind of simulation as well, which is PSpice. We have also called the open source software like LTSpice. We have MATLAB. We can run through MATLAB. We have Opera, whatsoever. But why we choose PSIM? Because PSIM is the most user-friendly modules or simulation tools available at the time being. And because in PSIM we just can click and connect without complex parameter to set inside our simulation tools or simulation environment, so we can understand actually how the power converter works. And the most important is that we are able to understand how actually the things or the converter is working, and not to expert in terms of how to create the topologies itself. And the topologies is there, but how to understand the working principle of the topologies. So that's why we focus on PSIM, the most user-friendly simulation tools. And then we're going to learn about application and protection of power electronic converter and switches. So when we convert certain power, we are talking about few amperes up to 100 of amperes, and few amperes up to 100 of amperes. So when we talk about losses, and P is equal to VI is equal to V square over R equal to I square R. So this is equation of power. So if we are talking about losses, So if we have a high current here with a high resistance, so there will be a high losses throughout our circuit, throughout our converter here. And so same goes to the diode. Let's say we are passing current, we are passing the current through a diode. Let's say we have a diode, the voltage drop across the diode maybe 0.5 volt, let's say, but you are passing 100 ampere of current. So the losses throughout the diode going to be P equal to VI. Voltage drop across the diode plus, times the current that flows throughout the diode. So we have here voltage drop of 0.5 times 100 ampere. So it will be 10 watt and 10 watt. So 10 watt if the diode is very small, and we are talking about SMT, surface mount technology or surface mount device. So 10 watt losses, and we are talking about the losses throughout this diode. So how much the heat that you will face or you will feel on the diode itself, and 10 watt maybe will burn out the diode. So that's why we have to take care on the power electronic converter protection. How to protect the device itself or the converter itself from the deteriorating or the damaging current or the damaging process or the process itself, process that happen. Because we are going to design and fabricate and deliver the converter, and we hope at least the converter will operate throughout their warranty. And you are assigned as engineer. When you design something, you produce something, you sell the product, at least you can ensure that your product will live or withstand up to the warranty period. If let's say you supply the product to the market, then it come back after 1 week damaged, you have to replace again. So you bring no profit to your company except losses. So sooner or later you'll be fired from the company. So we have to take care on the application and protection of the device itself. We are talking about protection on the device itself, not on the user. So this is protection on device. So in terms of the learning approach, by right, our subject now, we are going to use or going to have a approach of face-to-face, because the subject at the end we shall have a face-to-face exam. Okay, face-to-face exam. But due to some circumstances, so we have decided that for the first half semester, which is up to your Hari Raya break, you shall have a online approach. Means that 2 hours of synchronous and 1 hour of asynchronous. So for our G3, we shall have a class on Tuesday morning, 2 hours synchronous, and then Tuesday 1 hour evening as a asynchronous. So I shall upload the notes for asynchronous one. We shall meet throughout Gmeet for synchronous class. Okay, and then after you come back after Hari Raya, so make sure you book your ticket and come back to Unimap. No excuse, unless we have what's so called any updates or changes. So make sure you return back to Unimap on time. So we shall have a face-to-face or the class and lab. So again, this the class is Tuesday. The lab, we have 2 session lab, which is group A and group B. And group A on Thursday, group B on Friday. So I have published the list, so you just log in, edit the group that you wish to be in, either group 3GA, group 3GA or 3GB, Thursday or Friday group. So it's up to your own choice. Okay, the tutorials, maybe during the lab hours we do not have lab, so it will be tutorial hours, tutorial hours.